induced C की. Are we good up to coefficient A, B, and C? Coefficient A because of asymmetrical horizontal soft iron or rods basically about the compass. B was because of the forward and aft component of the rods. C was a thwart shape component of the rods that we saw. If there is a rod forward and aft, either vertical or horizontal, then we have seen that coefficient B is caused. Similarly, C के बारे में भी देखा. Now we already know that when the ship is being built, there is a permanent magnetism is developed, and the orientation of this permanent magnetism depends on the heading when the ship was being built. If she was being built heading north, then the bow side will have a red pole, stern will have a blue pole. Are you able to imagine? Magnetic lines of forces, the ship getting built on north heading, the forward part red, the aft part blue. Okay?
Yes, sir.
Yes, sir.
Okay. If she is being built on a southerly heading, the stern is red, the bow is blue. All right?
Yes, sir.
If she is being built at say 90 degree, then port side red, the starboard side blue. When built with 270-degree heading, then the starboard side red, the port side blue. Okay?
Yes, sir. Tower side.
So we'll go to the board to discuss about this. Let me set up the camera. All right. Board visible?
Yes, sir.
Yes, sir.
Okay. So what we are saying that when the ship is getting built, she acquires a permanent magnetism. The blue, the magnetic lines of forces are like this. Earth's horizontal force is like this. When the ship is getting built like this, the red pole is forward. When she is being made, the red pole is stern. When she is made like this end is red. When she is made like this end is red. Of course, the other side will be the next pole, the blue pole. Now, if you see in this case, when the ship is heading after being built, she is sailing. When on this heading, H is like this force is also like this. Is that correct or not? The permanent magnetism, P, is also acting like that. So, deviation here is going to be nil. Is that correct?
Yes, sir.
Now, what happens if the same ship with the forward bow, forward side, having the red pole is like this and heading on this 180 degrees? What is happening here?
So the directive force will reduce.
Will it reduce or it will add up?
So it will reduce because the line. No, it will add up, sir. Add up.
Add ups are reduced in the same direction of magnetism.
But this will still remain same. EF here is maximum, EF here is minimum, but the deviation is nil. Correct? Now, in
Yes, sir.
this case, if we see, opposite is the case. The magnetic lines of forces H is like this. In this case, at 180 degrees, the directive force is getting maximum. This was at 000 course. This was at 180 degrees course. This is the first case when the ship was being built with heading north. When heading south, the directive force is maximum when on 180 degrees, but minimum when she is going north like this, and the stern is red. Correct? So what we are saying here actually is that when the ship is getting built, what we refer to as the ship's head when building or when being built. So these are the cases. The heading of the ship was north when being built, or 000 when being built. This was the case when we talked about this ship was having a course or heading of 180 when she was being built. Here 90 degree, here 270 degrees. So in this case, there are two. Let us say, take one example for understanding this. When the ship was being built like this 000 is what we refer to as ship's head when being built. And this one is known as natural, not natural. Natural zero heading. And on these two courses, the deviations are nil. The directive force becomes maximum or minimum, but the deviation is nil. In this case, the horizontal soft irons will get magnetized or permanent P is created. In this case, is there any Q?
No, sir.
No, sir.
So this is nil. Also, when the ship is getting built like this, P is all there, but Q is also nil in this case. The forward aft component P is maximum on this heading and this heading, but the Q force is 0. On the other hand, if we see the ship is being built like this, the horizontal component, only the athwartship component is going to get magnetized. So is this Q?
Yes, sir.
But this one will be nil because it is perpendicular to the lines of forces. So forward aft, this is basically responsible for B and this is responsible for C, rather PC and PB. What we are actually talking about is hard iron deviation. The combined effect of the two, combined effect of PC and PB is called hard iron deviation. Now, as we have seen on 000 and 180 courses, only P force is there. On 290 and 270, only C force is there. Sorry, PC is there. But what if the shape was getting built on a heading something like this? There is horizontal soft iron or horizontal magnet and horizontal, both of these, but one is athwart shape, other one is forward and aft. In this case, both of these will acquire the red pole. Is that correct?
Yes, sir.
Intermediate magnetism being developed because the lines of forces are like this. H is like this. So both of them are acquiring some bit of magnetism. This is responsible for PB and this is responsible for PC. So now what will happen in this case? When the ship is heading like this, after she has been built and she is out at sea, this is the heading this is the heading when she was being built, correct? And this one is natural zero, natural zero direction, correct?
Yes.
Now, in this case, the deviation will be zero. Because some part of this is like this, some part of this like this. So the resultant of this will be in this direction, which is either opposite to this or supporting this, but this is in the same line. The resultant of C and B, or rather PC and PB, is again in the same line. So the heading will become, sorry, deviation will become zero. However, the magnetic directive force will become maximum or minimum depending on the course. So this is the resultant of PB and PC. This kind of deviation, which is the resultant of PB and PC, is known as hard iron deviation. This has got a different effect than what we have seen so far. We have seen A, we have seen B, and we have seen C coefficients. But in this, both of them are existing together. So it is not at 0 degree और 90 degree पे change नहीं होता. यहाँ पे zero deviation is available only at the natural or neutral courses. Neutral courses are these. एक इधर और एक वापस 180 degrees. Are we getting? कहानी समझ में आ रही है थोड़ी सी?
सर इसको नेचुरल जीरो क्यों बोलते हैं सर?
Natural zero because in this two conditions the deviation is going to be zero. Is that correct or not?
यस सर.
So इसके लिए this is natural zero.
ओके सर.
Yeah, simple as that. The heading on which he was being built is named by the same thing, heading when built. और उसके opposite में भी zero मिलता है. 180 degrees apart course पे भी zero मिलता है. So that is
Yes, sir.
called natural zero. Only the directive force at one place will be maximum, the other place will be, one heading will be maximum, other heading 180 degrees away will be minimum. So if we try to study this, let us say the same case, when the ship was getting built like this, on this heading, let us say,
सर लास्ट वाला रिपीट कर देंगे, मेरा नेटवर्क ही चला गया था, कुछ पिछला क्या पड़ा कुछ भी नहीं पता चला.
ओके, लास्ट कहाँ तक सुना आपने?
सर मेरा बीच में ही हैंग हो रहा था, मेरे ढंग से कुछ हुआ नहीं, मतलब सिर्फ ऑडियो आ रही थी, वीडियो अटकी हुई थी.
Okay, so what we actually said, we said, in short, अगर पूरी चीजों को करें तो जहाज जब जिस हेडिंग पे बनता है, when getting built, this heading is known as the ship's head. When built, and the opposite course is called natural zero direction. On whatever heading she is being built, the magnetism will develop in line with the Earth's magnetic field. जहाज ऐसे बने तो यहाँ पे रेड बनेगा. अगर जहाज यूं बन रहा है इस हेडिंग पे तो रेड यहाँ पे बनेगा, ब्लू इधर. अगर जहाज यूं बन रहा है 90 डिग्री पे तो रेड यहाँ पे होगा, अगेन in line with this. When the ship is getting built like this, तो यहाँ पे रेड बनेगा, यहाँ पे ब्लू. When the ship is getting built like this, then the red will be here. Again, when she is being built on this heading, the red will be here, blue will be here. So on all these courses, when the ship is being built on this heading and on this heading, this magnetic field due to the iron of the ship, it is only either adding to the DF, directive force, or it is subtracting from the DF. But in all these cases, this heading and this heading, the deviation is nil. So she was being built like this with a heading something like what we are saying is 240 degrees, 250 degrees or whatever. So when the ship rolls out, goes into the sea, and when she is heading the same 240 degrees of course, during that time, the deviation is going to be zero. Or when she is going opposite to that, 240 minus 180, that is 60 degrees, then also the deviation is nil. Take 2 minutes, think about this, what we just said, whether it is making sense or not. try to think of this. I'm keeping shut for 1 minute. I'm asking you to think about this situation. Maybe you can draw a diagram, take any course when the ship is being built. So one heading when she was being built will be named ship's head when being built. The other end, 180-degree, will be called the natural zero direction. And ascertain yourself that on those headings, the deviation will be nil. Please do that exercise for me. Try to get your understanding clear. एक diagram बनाइए अपने आप से and talk to yourself, teach yourself. I'll take a glass of water. Just one second. Are we doing okay? Yes, gentlemen. Still working out.
बना रहे.
Okay, okay. जो अभी आप सोच रहे हैं, जो कर रहे हैं, उसके साथ साथ एक चीज और समझ लीजिएगा. मान लीजिए आपने कोर्स एक लिया समथिंग लाइक दिस फॉर एग्जांपल. तो इसमें देयर इज P, देयर इज Q. Q is the component permanent magnet का athwartship component. P the forward aft component. We have seen the coefficient P is due to forward aft component, where there is PB, which is because of P. Permanent B is caused because of P, and coefficient C is athwartship component, where PC is caused by Q, which is because of this, and this is because of this. In this case, both the ends are developing the red pole here and the blue pole here. That means part magnetism here, part magnetism here. What we are saying that there is PC developed here and PB developed here. The combined effect of PB and PC is that it is having a direction like this, which is in the same line of H. That means either it is going to add to this or it is going to subtract to this H, but the direction will remain same. When the shape is being built with more towards 90 degree, that means this athwart shape component will be more and this will be less. So again, the resultant is same on the same line, the PC being high and PB being small. Resultant still remaining in the same line. That means the deviation are nil on this courses when the ship is being built. And also opposite to it. Are we good?
Yes, अभी बना रहे.
ओके बनाइए, देखिए, समझिए इस चीज को. टॉक टू योरसेल्फ. इफ नॉट, इफ सम प्रॉब्लम, देन डू लेट मी नो. आई एम watching out. I'm waiting here. क्या कहते हैं, सही चल रहा है?
हो गया.
Okay. So if we see, let us say, when the ship was being built, she was on a heading 135 degrees, for example. The red is here, the blue is here at this end. The ship's magnetic field is like this. The compass here is matching with H, so deviation is nil here. Opposite to that, when she is heading, then this side is red, this side is blue. Then also deviation is nil. What happens if she is going on a northerly course? It is here, blue is here, blue is here. The compass is like this. What kind of deviation she is going to have? What kind of deviation she is going to have?
Where, sir?
Westerly, sir.
Why westerly? Easterly, because she is going to get pulled. The red component, red of this is here. कंपास का रेड यहाँ पे है, ब्लू यहाँ पे है, तो इस तरफ को जाएगा या नहीं? 90 degree from this, when she is heading here, the compass is like this. The red here, the blue is on this end, blue on this end. Then also there will be maximum easterly deviation.
Yes, sir, maximum.
Here also something similar. It is like this. The blue is here and the blue is here. So again, it will go to this side, deviation easterly. If we take this course, the blue end here, the red end here, the compass is like this, where the red is here. What kind of deviation?
So westerly.
Very good. Deviation westerly. So on all the 180 degrees to the left of the natural zero is all westerly deviation. On the right of this natural zero, all around 180 degrees, there is going to be easterly deviation. This is the case when we are thinking that it was being built on 135, heading 135. If she was being built, okay, understand this, take clear your understanding about this, that it is all right. इस केस में the compass is like this, the red pole is here, blue pole is here. ये permanent magnet है, hard iron magnetism. So here also westerly, the red being at this place,
Yes, sir.
the blue being here.
Yes,
So
sir.
she will be attracted to this. this side. So on the left of the natural zero, all is westerly heading, a westerly deviation. On the right of natural zero is 180 degrees, is easterly deviation. If she was being built, for example, when she was getting built, if she was on this heading, okay, when she was being built like this, the heading when built, in this case, the permanent magnetism will be developed like this, correct or not?
Yes, sir.
एंड यहाँ पे आपका कंपास है, तो कंपास का भी रेड इधर होएगा. इस केस में H and this two are going to be in the same direction.
Yes, sir.
So
It,
in
it
this
will
case,
reduce the DF.
DF को reduce करेगा, but deviation will be
Nil.
very good, nil. So we understand it immediately to the right and immediately to the left, and our understanding should be clear then. So when she is going here, the red pole of the hard iron is here, red pole of the hard iron is here, and the compass is like this, where the red end is here, and compass is like this when the red end is here.
Sir, no, below will be westerly and above will be easterly.
So again, to the left, what we are having?
So easterly,
Easterly. And to the right, what we are having?
westerly.
Exactly. So in this case, if we see the natural opposite का अगर देखेंगे, so this is sorry, this heading is the natural zero. This heading is the natural zero.
Yes, sir.
So here it was easterly, as you said. So to the right of this is again easterly, and to the left of this is all westerly. Deviation. So we are taking the reference of the natural zero, और उसी के रेफरेंस में हम देखते हैं कि to the left of this is westerly, to the right of this is easterly, which was also the case in this case. When the natural zero was here, we saw easterly there and westerly on the other side for 180 degrees. Are we getting somewhere? कंफ्यूजन हो गया कुछ? ठीक है ना?
Yes, sir. Clear.
So we are talking about the hard iron deviation, and as we have already understood and seen that when the ship is getting built like this, the forward aft iron is developing PB, permanent B, and the athwart shape is developing PC. The resultant of these two can again be obtained by the parallelogram method. So this is the resultant. Resultant hard iron. This is known as force O. We had P, we had Q, we had R. The resultant of PC and PB is force O. So in this case, if we take the name as A, B, C, D, इस case में what is the value of resultant? AC, which is the resultant force O, is it equal to this?
Yes, sir.
So hard iron deviation, HI deviation is equal to this. From here, we can also say that the theta, the deviation that it is going to cause, is tan theta is equal to PC by PB. अभी जो डायग्राम बनाया था हमने, where theta,
सर PC by PB होगा सर.
okay, sorry, PC by PB. This is the Q natural zero from meridian. जो हमने अभी बात किया था इस तरीके से. सो मेरिडियन ये है, we had this. This was the natural zero. This was the heading of the ship when being built. This is the natural zero. This angle from the meridian is what we are talking about. Basically, this angle we are talking about is the theta. This is the deviation, which is going to be the deviation, in this case westerly. ठीक है? So this is about hard iron. Hard iron deviation is what we discussed today. We'll note down few things about the other coefficients. Let me sit down. All right, write down coefficient D. Coefficient D.
So delta.
Coefficient D. Definition of coefficient D. Coefficient D is the maximum value of coefficient D is the maximum value of the quadrantal deviation which varies as the sign of SINA, which varies as the sign of twice the compass course, and is caused by a horizontal field at the compass position, caused by a horizontal field at the compass position
Sir, horizontal.
horizontal field FIELD, horizontal field at the compass position due to induced magnetism in horizontal soft iron, situated symmetrically about a fore and aft line through the compass.
About 4.5 line.
Through the compass. I will read the whole thing once again, starting from beginning till end. Coefficient D is the maximum value of the quadrantal deviation, which varies as the sign of twice the compass course and is caused by the induced magnetism, and is caused by a horizontal field at the compass position due to induced magnetism in horizontal soft iron situated symmetrically about a fore and aft line through the compass. All okay?
Yes, sir.
Okay, next paragraph. The soft iron may be forward, aft, or athwartship. The soft iron may be forward, aft, or athwartship. Full stop. The SI being horizontal, the soft iron, SI is soft iron. The SI being horizontal, they are magnetized by H of the Earth magnetic field.
Sir, they are magnetized by?
magnetized by horizontal force of the earth. ऐसा लिख लीजिए, horizontal force ब्रैकेट में h डाल दीजिएगा, horizontal force h. So now we have a new type of deviation which is happening at the rate of twice the sine of the course. If the course is 45 degrees, the applicable deviation will be at 90 degrees, sine of 90 degrees. If we are doing a course of 20 degrees, it will be sine of 40 degrees, twice the course. And this is caused by the horizontal field which is available at the compass position, and it is by induced magnetism in the soft iron which is located near the compass in forward aft line. So leave little bit of space, about 6 inches of space below what you have written. We'll make a diagram. Time तो finish हो गया. Let us complete this itself. अगले वाले को अगले इसमें करेंगे. Just make a diagram. Just 1 second. So we have got this D thing coming up. There can be a possibility of course, we know there can be plus D or there can be minus D. This is going to be caused by definition. जरा बताइएगा मुझको. Definition के हिसाब से क्या कहता है? किससे होगा? D is created by soft iron, correct?
Yes, a soft iron caused by horizontal field at the compass position.
Okay. So if this is the compass, there can be a symmetrical soft iron which is running through and through, or there can be an two sets of rods separate from each other running like this. This will give rise to positive D. And the other one, minus D, will be produced by two separate rods aligned like this, or one rod continuous running like this. So this is continuous athwart shape or divided forward aft. Continuous athwart shape or divided forward aft. Soft irons. In this case, it is ulta. It is divided athwart shape or continuous forward aft soft iron. Once you have written, please let me know.
Yes, sir. Written.
Okay. So I'm just deleting this part because I have to make something more here. This will create what kind of deviation it is creating? Is it continuous, static, semicircular? What kind of deviation it is going to cause? Quadrantal. That means it will be in 4 quarters, 4 types of deviation: westerly, easterly, westerly, easterly. On the other hand, it is easterly, westerly, easterly, and westerly. On these courses, there will be error deviation which is easterly. For 90 to 180 will be westerly, 180 to 270 will be easterly again, 270 to 360 will be westerly. So these are the kinds of deviation that the coefficient D is going to create. Remember that it is because of soft iron and it is magnetized by the horizontal field of the earth, which is H. So at certain times there the H will be more, H will be less. So near the equator this will be more prominent, H will be more, and so there will be more of this magnetization, all horizontal soft irons. As we go up in the latitude, the magnetization will reduce, the effect will be reduced here, but H के साथ साथ जैसे ऊपर जाते हैं तो H भी कम होता है, ये भी कम होगा. So ले देकर के again the net deviation it is going to create is going to be same. That's my understanding, that since it is soft iron and horizontal, तो H बढ़ेगा तो ये भी बढ़ेगा, H कम होगा तो ये भी कम होगा. Now कितना कम ज्यादा होगा वो proportionality will depend कि what is the length and situation of the irons and all that. But it will be quadrantal. All right.
Yes, sir.
So some more studies that you have to do about this. One thing that I want to end the class with is that since it is soft iron and it is going to create some deviation, so it has to be corrected. What should we use for correction? Now common sense should have come about compass to know that this soft iron magnetism will be corrected by what? Which kind of corrector?
Quadrantal spheres.
Come again?
Quadrantal spheres.
Yes, the spheres basically soft iron से ही counter होगा, क्योंकि ये soft iron है which is getting induced by H, so we need another soft iron in ulta direction to counter the effect of this. So that will be again a soft iron corrector. All right. So we'll see in the next class. Bye bye.
Oh, thank you.
All right. One more thing. April batch. आपका सिर्फ gyro compass बचता है. Is that correct?
Yes, sir. Gyro.
Okay. So magnetic compass almost complete होने को है. एक दो क्लास जो मिलती है उसमें हम लोग ट्राई करेंगे कि whatever we are able to complete. Then next week onwards we'll start the gyro compass. Bye bye. Signing off.
Bye, sir. Thank you.
Bye bye. Thanks.